So some of you guys had questions on problem number 4. This is from the Q2Day23 homework assignment, page 230, problem number 4. It's talking about, or it's asking you to find the dimensions of a right circular cylinder with volume 1000 centimeters cubed and surface area 600 centimeters squared. So before you can start solving this problem, a little quick refresher is that the volume for a right circular cylinder is V equals pi r squared h. So that's for the volume. And then for the surface area, we get 2 pi r h. So 2 pi times the radius times the height. So it's 2 pi r squared. Okay, so you might have had to look these up so that you can figure or so you can finish this problem, or in this point start this problem. You might have had to look this up, these formulas. So what I'm going to do is I am going to go ahead and set this volume formula, pi r squared h. Oops. So pi r squared h equal to 1000. And the surface area, I'm going to set that equal to 600. Okay, so what I'm going to do is I'm going to go ahead and I'm going to solve. I'm going to take this volume formula and I'm going to solve for h. So by replacing the volume with 1000, I was able to narrow this down to only two variables, the r and the h. Now I'm going to solve for h so that I can then plug it in to this h over here and solve the problem. So pretty much I'll have h equals 1000 over pi r squared So now what I'm going to do is I'm going to take this, and I'm going to plug it in right there. So what I now have is 2 pi r times 1000 over pi r squared. So it's 2 pi r squared equals 600. Okay, and go ahead and simplify this. In order to save time, I'm going to go ahead and pause the video, solve it, and you guys pause the video too, solve it, and simplify this. Don't necessarily solve, just simplify. Do all the work, and I'll continue with you guys in a bit. Alright, so this is what I got. So here's the work. So all I really did was I took my two formulas, and what I did was I solved one for h. You could have solved for r, but it's a lot easier if you just divide both sides by pi r squared and get h. And I did that so that I could then plug this into this second formula here and go from having two different variables to just having one variable. So in this case, we just have the variable r for radius. Okay, do some algebra, and once we get to this step, we can go ahead and subtract 600r to both sides to get 2000 plus 2 pi r cubed minus 600r equals 0. From this point, what you would do is you would solve for r, but this is kind of hard to solve without a calculator. And the nice thing about this problem is that number 4 is not a shaded problem. So it's not shaded in gray. That means we can't use the calculator for this problem. So using your graphing calculator, I'm going to make this left side, I'm going to plug in 2000 plus 2 pi r cubed minus 600r for y1. And I'm going to plug in 0 for y2. So I'm going to plug this into my graphing calculator, and where the two lines intersect, those are my two solutions. So one thing that I am going to do though is, since there is no r variable in my graphing calculator, I'm just going to go ahead and I'm going to put the r's as x's. Okay, so you would go to y equals, and for y1 there is that left side of the equation. Notice that instead of r cubed I have x cubed minus 600x, and then for the second equation I have just y2 equals 0. I'm going to hit graph, and there they are. So there's the left side of the equation, there's obviously y equals 0, and where they intersect, just like I said, where they intersect, those are your answers. So notice we're going to have two solutions here. So you can use your graphing calculator to calculate the intersection. Go to second, trace, and the fifth one is intersect. You just got to tell you got to guide your calculator as far as what intersection you want. So use your cursor. You want to get really close. Use your cursor to get really close to the intersection that you want. So I already passed it. Okay, let's see. So notice that I'm using this as a guide. So 1, 2, 3, 4, somewhere around 4. So my cursor is it's not appearing here, but we're close enough to this first intersection. I'm going to hit enter. And I'm going to go ahead and hit the second curve. Hit enter again. Guess the intersection. So there it is. The intersection is 4.0071302. So going back, we have one solution is r equals, let's just round it to 4.01 centimeters. So let's calculate the second intersection. So I'm going to do second trace, number 5, to calculate again. So there it is. You move the cursor really close to the intersection. You're kind of guiding your calculator, telling it what's the intersection that you want to focus on. So I'm going to hit enter for the first curve, enter again for the second curve, and then the third time to guess it. And there it is, 7.1315401. So approximately 7.13 centimeters. Okay, go ahead and plug these R values back into your H equals. So back in here, plug in the two R values that you found to find your two corresponding H values, your two corresponding height values, and your answer should be, these are approximately, by the way, approximate 19.82 centimeters. H is approximately 6.26 centimeters. And then finally, I also want to clarify this problem here from Thursday. So, especially in first period, we had a hard time with this. Well, understanding the derivative part of this. So take the derivative of 2x minus 2x squared. I'm going to use this method instead of the left one so I can avoid the product rule. Set that equal to 0 to get my critical number. So x is equal to 1/2. So I had some students then tell me, okay, so then y is going to equal 1 minus 1/2 to get 1/2. So y is 1/2. So y equals 1/2 is one of them. The second one, however, is not 1/2. X is not 1/2 because remember that the x that you found was here. So with another 1/2 together it makes 1. So the dimensions that we should be using should have been 1/2 by 1. Okay, so I know some students were saying y equals 1/2, x equals 1/2, and I was saying that's not the answer. So you weren't wrong. You were just not really finishing it off. So the dimensions are 1/2 by 1 because when you found x equals 1/2, you only found this part, and you needed to find the whole base here. Okay, and that is it for this video.